Today we are looking at monomials and specifically looking at adding and subtracting monomials. So first let's start with our definition. A monomial is a number, a variable, or a product of a number and variable, or sometimes variables. So it's a number, a variable, or a product of a number and a variable. Okay. Another way that you could think of it is an expression with one term. So a monomial is really just an algebraic expression that only has one term in it. So some examples would be 5x, 10, 8x squared, 7x cubed, y to the fourth, negative 5/7. Each of these pieces on its own is a monomial. Whenever we have ones that have the same variables, right, so these letters, and the same exponents, so the letters and the exponents match, those are like terms. So, for example, a like term to 5x might be 3x. Right? Same letter with the same exponents. A like term to 8x squared could be negative 6x squared. A like term to 7x cubed y to the fourth could be 2x cubed y to the fourth. So they have the same variable with the exact same exponent. So this is similar to what we did earlier in the year. Now if we're going to add or subtract monomials, all we need to do there is combine like terms. The variables and the exponents won't change. We will just change the coefficient. So, for example, for number 1, we have 17x minus 25x. These have the exact same variable in the same exponent, which is technically 1. So this is 17x's minus 25x's. So what we are going to do is take our coefficients and combine them. So we really have 17 minus 25, which gives us negative 8x. Looking at number 2, we have negative 23y squared plus 6y squared. Our variables are the same, they're both y, and they both have the exact same exponent of 2. So these are like terms, which means we can take these coefficients, negative 23 and positive 6, and we can combine them together. So negative 23 plus 6 is negative 17. And our variable and our exponent stay the same, right? We are not changing the letter or the exponent. So we look at number 3, we have negative 15a cubed bc plus 6a cubed bc. Each of these terms has a, b, and c. A, b, and c. And then for each one, the a has an exponent of 3. So they match exactly, which means we can take our coefficient of negative 15 and positive 6, and we can put those together. Negative 15 plus 6 gives us negative 9. And then I'm going to copy my variables and exponents. So we have a cubed b, c. And we can only put things together that have the exact same variable and exponent combination. So for example, if we look at number 9, we have 3y plus 9z plus 4y minus 3z. We can combine these two together because they're like terms, they both have a y. But I cannot combine this 9 with the 3 and the 4 because it has a completely different letter too. So 3y plus 4y gives me 7y. And then I can look 9z and 3z have the exact same variable, so I can combine those together. So we have positive 9 minus 3 leaves us with positive 6z. Lastly, with adding and subtraction, at number 12, we have 10m squared n plus 7mn squared minus m squared n. Now, all three of these terms have an m, an n, and an exponent of 2, but they don't all match exactly. So, I can only combine this 10 with something that has an m squared n. So even though this has an m, an n, and an exponent of 2, these variables and exponents don't match exactly, so I cannot combine this 10 and that 7. But our last term here has an m squared n, so that matches exactly. So our last term and our first term are actually like terms, so we can combine them. So this is 10 minus, remember there's a 1 here if there's nothing written. So we have 10 minus 1 leaves us with 9m squared n. And then the 7mn squared doesn't have any like terms, so it just stays exactly how it is. So with adding and subtracting, you're looking to match your variables and exponents. And once you find a match, you're going to combine your coefficients, so these numbers in front. X to the a power, where this could be any number, times x to the b power. Our answer is going to be x, right? So we still have our variable, and we're going to take these exponents and we're going to add them together. So it ends up being x to the a plus b. So let's look at what that looks like. If we had x squared times x to the third, our product rule says that's x, and then we're going to take our exponents and add them together. So it's really x to the 2 plus 3, which is x to the fifth. So if we had a to the ninth times a, and if there's no exponent, that's really the first power. Our product rule says that's going to be a to the 9 plus 1, or a to the 10th power. So when we multiply monomials, we add our exponents together. So w to the 7th times w to the 4th is going to be w to the 7 plus 4, which is actually 11. So anytime we're multiplying, we're going to take those exponents of the same letter and we're going to add them together. All right, we're going to do a couple of practice problems. We're going to start with number 20. We have 4x squared times 3x to the fifth. Now we're still going to do x, and we're going to add our exponents. So 2 plus 5 is 7. Now the piece that's different here is this coefficient still follows our normal multiplication rules. So we're just going to multiply our coefficients together. So 4 times 3 is going to leave me with 12. So when you have a coefficient, we're going to multiply the coefficient together and add the exponents. So looking at 21, we have 3x to the 6th times 5x squared. We're going to do 3 times 5, which is 15. We're going to have an x, and then for our exponent, we need to do 6 plus 2. We're going to do the same process even if there's multiple variables within the problem. So for example, number 23, we have negative 4a cubed b times 3a squared b to the fifth. We're still going to take these coefficients and multiply them, so negative 4 times 3 is negative 12. And then we have an a. Our new exponent for the a is we're going to add these exponents. So 3 plus 2 gives me 5. And then we have b. We need to add the exponents from b. So we have 1 plus 5 gives us 6. So we end up with negative 12, a to the fifth, b to the sixth. We're going to do 2 more together before you start moving on to your practice, and we're going to do 2 from the bottom section. So looking at number 35, we have 2x to the fifth y squared times 4x y cubed plus x to the fourth y to the fourth times 3x squared y. So this is a problem that has multiplication and addition. We still have to follow order of operations. So we cannot do anything with this adding until we take care of the multiplying first. So here we have 2 times 4, which is 8, x, and we're going to have 5 plus 1. And then y is going to be 2 plus 3. So that gives us 8x to the 6th, y to the 5th, plus, I'm just going to bring down my plus sign. We have 1 times 3, so 3. X, 4 plus 2 is 6. And then for y, we have 4 plus 1, which is 5. So now we've taken care of our multiplication. And when we look at this, we now have two monomials that have the exact same variables and exponents. So now we've created a situation where we have like terms, so we can do this addition. So remember, with adding, like we talked about on the first page, we're only combining these coefficients. So we're only combining 8 and 3 to give us 11, x to the 6th, y to the 5th. Looking at number 36, this will be our last problem that we'll do together before you start your independent practice. We're going to do 4 times 5, which gives us 20. A, we are going to add our exponents, so 3 plus 1 gives me 4. B, we have 4 plus 2, which gives us 6. Plus 1 times negative 2 is negative 2. A, 2 plus 2 is 4. B, 5 plus 1 is 6. So we have 20, a to the 4th, b to the 6th, plus negative 2, a to the 4th, b to the 6th. So now we, again, have created like terms because we have matching variables and exponents. So we can combine these coefficients. So 20 plus negative 2 leaves us with 18. And remember, when we're adding, these variables and exponents stay the same. So a to the 4th, b to the 6th.